Hello college algebra student. This video is for chapter 3.4 part 1, composition of function. So we are wanting to at some point in time sometimes we like to have an input, go to a function, use the g function, and so we will have g of x, right? But then I will use this as an input of another function f. So basically this is the x, this is the input of f, but it is the output of g, right? So it becomes f of g of x. So you can think of g of x as the input of f, but it's the output of g. And so you would have the second time input of f of g of x. So this situation is known as composition. You are doing two functions in step. And we call this from x go to f o g of x. O because of composition. So fog. So this is just a new function's name. So if we want to write a sequence of functions, go from g first and then to f, we call it f o g of x. Notice the sequence is not going. When I read it, I say f o g of x. So it seems like I go from f first, but actually when we do it, we start from x. We say this is the input. It goes into g first, and then it goes into f, right? So this is how it goes. When you look at the setup, if someone write f o g, you know that x go into the g function first, and then after you find the output, you put the output into the f function. And it has a lot of application in calculus, so that's why we need to learn it. So if f of x is 2x squared plus 1, I have another function, g of x is 3x minus 5. I want to do f o g 2. Remember what we defined composition? If you see f o g, two function with an o, that means it's composition. You go from 2 go to g first, so we would use this first. So the f is waiting outside. Just write it, copy it, and then you say g of 2 is 3 times 2 minus 5, right? So you see how you have f of this as being the input. 6 minus 5 is 1, so that it becomes f of 1 because after you put 2 in here, it becomes g of 2's answer, the output is 1. Now we're going to put 1 into f. So it'll be 2 times 1 squared plus 1, that is 3. So f of g of 2 is equal to 3. We can actually create a formula that can help us to do f of g right away by plugging in x. And that's how we do it. We would just pretend we put x into g, so I have the whole g of x as the formula. I'm going to put the whole formula into f. That's actually what it is. So use this as the input. Write it here, 3x minus 5. This is the whole g of x formula. And this whole thing is going to plug into f. So in f, the x is a placeholder. So you would say 2 something square. So you can rewrite it as 2 something square plus 1, right? This something is the g function, 3x minus 5 square plus 1. So that's how you do it. And of course, if you want to combine right term with the 1, you have to FOIL everything out. So 3x minus 5, 3x minus 5, 3x minus 5 times 3x minus 5. You have to FOIL it. It will be 9x squared minus 3 times 5, 15, and then 15, 30x plus 25 plus 1. And if you multiply it out, it will be 18x squared minus 60x plus 50 plus 1. And then simplify, it will be 18x squared minus 60x plus 51. So if you do not want to go step by step, if you want to do f o g of x, that means go through g and then go to f, you can just plug it in here and you will get this right away. What about g of f of x? We can actually This means that I'm going to put x into f, so I have f of x. This is the formula. I'm going to put the formula into g. So let's look at the g function is 3 something minus 5, right? So what is my plug-in? It's g of f of x. What is f of x? F of x is 2x squared plus 1. It's just a formula. I'm going to put this formula into the g formula. So that would be 3 times 2x squared plus 1 and then minus 5. This would be easier. There's no foiling. 6x squared plus 3 minus 5 equal to 6x squared minus 2. And that's the answer for g of f. And you notice that f of g and g of f are not the same because you go to different formula first, but like the sequence is different. Let's do another formula example. If my f of x is 2x squared plus 1, g is square root x, what is f of g of x? So this means that x go to g first, it become a g of x and formula. F is the second step, so you say f need to get the whole g of x as the input, right? So what is f? F is 2 of something. So what is this something? Is the square root x. So you will say 2 of this square root x square. So remember, if you are to write this, is 2 something square plus 1. So remember, x is just a placeholder. You put it here, and then you still have to do plus 1. What is square root x square? It's just x, right? Square and square root cancel. So 2x plus 1, and that's it. G of f, the other way around, I'm going to put x into f, so it become a f function, just a formula. But you want to put this whole formula into g, so into g. So you write it like this. You write as g of the whole f of x formula, which is 2x squared plus 1. But what is g? G is a square root of something. What is the something? Something waiting for you to input. It is 2x squared plus 1, so it will be square root of 2x squared plus 1. And that's the simplest form. Next one is more complicated. We have fraction. So I'm going to do this because we want to know how to do this complex fraction. So again, I have f of g, that means x go to g first, which is just the g formula. This is g of x. And I'm going to take the whole g of x and put into f. So that is equal to f of what? The whole g of x, 1 over x plus 2. But in my f, I'm going to put this in f. The placeholder is here, so I have to say, well, 4. And then I'm going to put this whole thing in. 1 over x plus 2 minus 3. So I would have 1 over x plus 2. Because this is the placeholder, I stick everything in, and then minus 3. So in the denominator, I have a plus 2 minus 3. I can simplify that part. But my 1 over x is the trouble, right? Oh no, this is minus 1. How can I simplify this? Because this is kind of odd work. You have a fraction and then a fraction. So you look at the denominator. I have a denominator here, which is x. So I multiply x over x. Because I don't change anything if I multiply x over x. So the top would become 4x, but the bottom would be 4x times x is 1, minus 1 times x is x. And I clean up this denominator. So distribute. So that's the answer. Let's do f of g of x. So my f is the formula that I want to put, and I want to put the whole f of x into g, so I can write it as g of the f formula. What's the f formula? It's 4 over x minus 3. So this is just something. I'm going to stick it here. Where should I put it? It's 1 over these things. So I would write 1 over of the, you can think of this as 1 over something plus 2. But this something is in another fraction, 4 over x minus 3. Does it make sense? 1 something plus 2. So 1 over a fraction is just a reciprocal, right? So you would just flip it around, x minus 3 over 4. I don't need to do those multiplying things because this is different from that. It is 1 over. So if you say 1 over 2/3, that is 3 over 2, right? Because this is just like that. And plus 2. So you can just keep this. This is a fraction plus 2. So this is the function composition. You need to know how to do this. And then we have a work problem. So let's look at this. So how can I use function composition? That means I put a input into something and then I put it into another function. For example, I have a demand function. The input is price. It's a demand function. If you put price in, it would tell you the number of items that you can sell. Okay, this is SO. So this would give you the number of items. So number of items. P is the price. But then C of X is used to calculate the cost of X items. So if you want to sell that many, you have to produce them, right? What's the cost of producing them? So it would be C of X, but X is D of P. So basically you would put the D of P inside, right? So what can be used to find the total cost when the price is set at 6? So the cost would be equal to C of D of P, right? Because you want to put this is the number of item and this X is the X item, right? So it will be C of D of, if your price is 6, then you would say C of function D of 6. And that would give you the cost. In the next section, we'll talk about decomposition. But it would be in the second part of 3.4.